So 4.4, we get a fun formula. We get to play with it. It's all good. You may recognize this formula as something that might have happened if you used completing the square sort of thing. Dun, dun, dun. Was that foreshadowing? Foreshadowing. So the first thing that 4.4 wants us to do is they do a construct understanding thing where they're like, throw these things into your graphing calculator, and you can do that. Make sure you get your brackets correct. What you're going to find when you do that is that you'll throw in a formula and you're going to look at the pattern, and hopefully you're going to discover that this point, P, so we're going to make it red, that point is the x of the vertex. And that Q, whatever's at the end here, is the y of the vertex. So, for example, I take my handy-dandy calculator and I go to the y equals sign, and I'm going to follow one that uses the same pattern as this one. First one says y equals x minus 1, so I'm going to go y equals bracket x minus 1, close bracket, square that, page over so it's not an exponent anymore, and then hit plus 2. Now I'm going to hit my graph option. Alright, now I'm going to work with you over here, show you. I got my graph here, and I can kind of see, I'm just going to put it on an angle so you can see the color a little bit better. Yeah, that's actually pretty terrible. There we go. That's nicer. It's a little out of focus, but it's okay. So we've got a parabola, and if we want to find the vertex of this parabola, then we're going to go second function trace, and since it's a down parabola, we're going to go with a minimum value. And then we're just going to walk our little blinky blinker over there, left bound, so it's going left across the screen, that way. Enter. And then move the little blinky blinker across the screen. Enter again because it was going right bound to get to the middle. And hit guess. And it tells me my minimum is at x equals 1 and y equals 2. So the formula that I put in was the first one in your book, y equals x minus 1 squared plus 2. My x for the vertex was 1, and my y for the vertex was 2. So if I would want to say what is my vertex point, it is at 1 and 2. Now, you probably are already thinking in the back of your mind, what about the signs? The signs for the formula to work, for the pattern to fit, the sign here has to be a negative and the sign here has to be a positive. If it is a negative and a positive, then great. It's like a little Lego block. You just whoop, out it comes. So this one, if it's positive, it's just positive. This one, if it's negative, it's positive, because you just plunk it out of the formula. You'll find that this one, whatever sign it's on, is what it is. So, for example, we'll try a different one, and I'll show you what I mean. I'm going to get rid of this one. And we'll try a little bit more complicated one. So, let's see. That one's no fun. They don't give us a really great one here. But there's one that says y equals negative 1/2 x minus 4 squared minus 7. So when we go to plug that one into our calculator, we're going to hit the y equals button. We go negative, I'm just going to use 0.5 because I'm a cheater, x minus minus 4 close bracket squared and minus 7. Hit my graph. And I can see it's a negative, so it's upside down. And I can see that I have a vertex, second function trace. It's a maximum because it goes up. 4, hit the maximum. And this tells me that my x is at 0, so it has to come across here. Oh, there it is. Okay, left bound. Put it over half to right bound, guess. And it tells me that my x is at negative 3.9 forever, which is positive 3.9 forever, which is just 4. And y is negative 7. So I made my little graph. It looked like that. This point was at 4. Wow. 4 and negative 7. That was that point. So I can see that negative 7 is here. This is a direct read from the formula. The bit of a trick is that the one that's in here, the x value, so there's the negative 7, the x value will be the opposite sign. So this is a positive 4. So you're just taking that out of there. Right? It's got to be x minus what? And the what is the coordinate that you're going to use. So we'll try one more using a positive value in here, and I'll show you how that works. Okay, one with the positive value. We've got y equals 2/3 x plus 2 squared. And that's it. It doesn't have a q. So what could you put there? It does have a q. It's just implied instead of explicitly stated. So I can expect that if I were to draw this, my y coordinate is going to be right along this line, and x plus 2 would have to change to x minus negative 2 to fit the pattern of x minus something. So you see how the sign switches. So I would expect that this would be somewhere over here. So I grab my handy dandy calculator and I clear everything out of here and make this a nice fresh start. 2 divided by 3. Whoops. I'm just going to make brackets to make sure that I've got this correct. So 2 divided by 3 is in its own set of brackets. And then I'm going to put the bracket for x plus 2 close bracket squared and hit my graph button. And you can see, dun dun dun, that indeed it is where I said it was going to be. Yay! And it opens up because this is positive. I'm not going to go through every single one with you because there's a bunch, but you'll get the idea. This is your x coordinate for your vertex. This is your y coordinate for your vertex. Whatever sign is here goes with the y. It's fine. It's a straight read. Whatever sign is here gets reversed because you're actually taking just that value out. The x minus stays the same.